ionic bonds. By ionic bonds, there's always one atom losing or gaining one of their valence electrons, so the electrons on the outermost shell. And there can be, for example, sodium. Sodium has 11 electrons, 2 on the first shell, 8 then on the second shell, and 1 on the third shell, and that one single valence electron can be given away, and now it becomes with a full octet on the second shell, and it becomes now sodium. And it is now a cation because it has too many protons. It has still these 11 protons, but only 10 electrons. No, it has one too much protons. It has now a charge of +1, because protons are +1, electrons -1. Another example would be the chlorine. Chlorine has 17, and chlorine could gain an electron, has been 18, and it has no electron too much, so it is too much minus. It is now -1, and now an anion. Cation is positive, and anion is negative. And they can come together and form then sodium chloride, for example, and then they have again a net zero charge. All ionic bonds as a compound form together, for example, sodium and chloride, as sodium chloride, they have a net zero charge. There can be such compounds with a plus or minus charge, but that are not ionic bonds but covalent bonds. And there are many of them in the human body, most of the times in solid forms in the human body. Ionic bonds as compounds are most of the times in the teeth and in the bones. Such thing like natrium chloride or sodium chloride can dissolve in water, dissociate in water, and when it is an electrolyte, because they are now plus and minus after again having dissociated again, and they can carry now an electric charge that makes them an electrolyte. And that is according to Gerard Tatoga and Sandra Gabrowski's Principles of Anatomy and Physiology book on the page 30 and 31. If you click this video away, then please tell me what the reason for it was, so that I can improve. Otherwise, hi and welcome. I'm trying to learn biochemistry today, ionic bonds, and after we've done with it, we're going to do standing yoga. And if you participate in the standing yoga, then is that onwards. Ionic bonds. When an atom loses or gains a valence electron, ions are formed. So it does not become a new element, it becomes an ion. It loses an electron or gains one. Positively and negatively charged ions are attracted to one another. Opposites attract. A positive one attracts another negative ion. When this force of attraction holds ions having opposite charges together, it is called an ionic bond. So if two ions holding together, based on the one being plus, the other minus, that is called an ionic bond. Consider sodium and chlorine atoms to see how this happens. So we're having sodium and chlorine, two types of stuffs. And sodium has one valence electron. Okay, sodium has one valence electron. Figure 2.4. Sodium has 2 electrons on the first shell, 8 on the second shell, and 1 on the third valence shell, on the last shell. If sodium loses this electron, it is left with the 8 electrons in its second shell, a complete octet. So the second shell is full of 8. That's why the 11th electron in total, because 2 on the first shell, is on the third shell. So 2 fit on the first shell, 8 on the second shell, and then something more on the third shell. But there was just one, but one comes away, and now the 8, where the 8, on the second shell, where the 8, and now that the 8 one is full. And that is called a, whatever they call it here, a complete octet. We might just read the introduction about chemical bonds first. We read the part about covalent bonds and the part about the hydrogen bonds already. But there was sometimes referred to the ionic bonds, so we're reading now the ionic bonds. It seems we should read also the chemical bond part. When this happens, however, so sodium has nothing on the third shell but the second shell full. When this happens, however, the total number of protons, 11 now, exceeds the number of electrons. Yes, there are more protons than electrons. There are 11. Sodium has 11 protons and 11 electrons. 11 electrons on the free valence on the free shells. The outermost is the valence shell on the free shells, and 11 protons in the middle. Now the one electron was given away, and now it has still the 11 protons, but only 10 electrons, and therefore it has one proton too much. As a result, the sodium atom becomes a cation, or positively charged ion. A sodium ion has a charge of 1 plus and is written Na plus. Sodium is written Na plus because in Latin it is called nature, and in many other languages sodium is called nature. On the other hand, chlorine has 7 valence electrons. 7 on the third shell, so it has 2 on the first shell, 8 on the second one, and then 7 on the other one, on the next one. 7. If chlorine gains an electron, if chlorine comes together with sodium, gains an electron, I think that's what we're talking about, from a neighboring atom, it will have a complete octet in its third electron shell. So the third shell can have also 8. So if chlorine gains one and has full on the third shell, also a complete octagon, you could say, a complete octet. When this happens, the total number of electrons, 18, exceeds the number of protons, 17, and the chlorine atom becomes an anion, a negatively charged ion. The chlorine could gain one. When it makes its shell full, the third shell of 8, now it has more electrons because it had gained an electron, but still in the center, in the nuclei, where still there was 17, or it was 17. It's 17 protons, and now it's a little plus. It is now called an anion. The ionic form of chlorine is called a chloride ion. And it's also known chloride ion if it has formed together with another element based on it having minus or the opposite charge as the other one with which it had combined with. When and it's written one minus and it's written Cl minus, chlorine minus, or it's chloride ion minus. When an atom of sodium donates its sole valence electron to an atom of chlorine, the resulting positive. But how can another chlorine get one? If it combines as an ionic bond with another chlorine thing. Now, the resulting positive and negative charges pull both ions tight together with an ionic bond. So one chlorine then sodium. When an atom of sodium donates its sole valence electron to an atom of chlorine, then they're pulling together. Because one is positive, one is negative. So if sodium battles up with chlorine, because sodium has one electron there, and that can be given away. And when it has 8 on the second shell, and the chlorine has already 7, it gets the 1, and now it's also full, and they're pulling tightly together. The resulting compound is sodium chloride, written NaCl. So sodium chloride, natrium chloride, sodium chloride. In general, ionic compounds exist as solids with an orderly repeating arrangement of the ions as in a crystal of natrium chloride. A crystal of natrium chloride may be large or small. The total number of ions can vary. The ratio of natrium of sodium plus and chloride minus is always 1 to 1. So it is a crystal that is most of the times pretty organized and pretty 1, 1, 1, 1, 1, and the ratio is always 1 sodium and 1 chloride. In the body, ionic bonds are found mainly in teeth and bones, where they give great strength to the tissue. That you knew it. Most other ions in the body are dissolved in body fluids. An ionic compound that dissociates into positive and negative ions in solutions is called an electrolyte. So if an ionic thing dissociates, then it's called an electrolyte. Because the solution can conduct an electric current, The chemistry and importance of electrolysis are discussed in detail in chapter 27. We are in chapter 2. When a single positively charged ion of sodium and a single negatively charged ion of chlorine form an ionic bond, the net charge of the resulting compound, sodium chloride, is 0. Because one was +1 and the other one was -1, and now we're having 0. There was one proton too much of one. So basically, electric charge comes through the, I don't know the word, through the lack of protons in something. So if there are too many electrons compared to the amount of protons. The same is true for every compound with ionic bonds. The net charge of a compound is 0. In your study of the human body, however, you will discover many compounds that are positively or negatively charged. For example, ammonium, which is NH4+, and hydroxide, OH-. And they are very common ionic compounds found in the body. The reason these compounds can carry a charge is that they are the result of covalent bonds, not ionic bonds. Now, we already did covalent bonds. I don't know what's now the difference. Wait, they got together. But one is stronger pulling the other one. What's the thing? They said here, unlike ionic bonds, covalent bonds can form between atoms of the same element, as well as between atoms of different elements. They said the ionic bonds could also sodium and chlorine, but also two different elements. Whatever, maybe it was about, I don't get no the difference, maybe it was about that one is pulling stronger at the shared electron. No, they're sharing, they are sharing. They're not giving the electron, they are sharing. That is the difference. Okay, ionic bonds, they are sharing, and covalent bonds, no. Ionic bonds, they are giving one, getting one, and covalent bonds, they are sharing one. It's then in the middle of the two. And when there are hydrogen bonds, and that is because the hydrogen, it's in a covalent bond, the hydrogen, if there's a covalent bond with hydrogen, the shared electron of the hydrogen is pulled a bit away, and therefore the hydrogen is a little positive, and it is now a little bit more attractive to negative things. That's all. That was the biochemistry part. If you're here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the stay in yoga. And this way, on the scale. The feet are standing together and we're breathing in and lifting arms up. Out the arms down. In and up. In and up. And out to the side. In and up. Out to the other side. In and up. Make an inch of space between the feet. And out again to the side. Up. And out to the other one. Up. Out the side again. In and come up onto the top. And out and sink a bit down. In and up. Out onto the side, heels down. In and up, heels up. Out a bit down. In and up. Out, lean onto the knees. Breathe in. Out the head of the back. In into the middle. Out the belly. In into the middle. Out the head. In into the middle. Out the belly. In into the middle. Out the belly. In into the middle. Out the belly. Out into the middle. And out comes slowly the round back up. Breathe in the arms up. Come up on the tiptoes, reach high. And out and down, feet together. Breathe in the right leg. Out and stretch left leg. In change. Out and stretch the right one. In the middle. Out and down. In at the right and up. Breathe out, bend the left knee, look to the right hand. Inhale down. Out and down. Breathe in left hand up. Breathe out, look to the left hand. In and down. And out and down. Make a hand with space between the feet, shift the weight to the heels and breathe in and go down. And out and up. In and down. Out and up. Take hold of the elbows and gentle rock from side to side. Hands down, feet together, breathe and come halfway up with a straight back. Out and down. In halfway up, straight back. Out and down. Breathe and the hands up. And bring the hands again down. Torso body to the outside, or in space between the heels. Breathe and lift the arms up. Breathe out, sink slowly down. Hands onto the ground with the back up. Roll slowly with the round back up. At the top of the good shoulder. In the hands up. Out and down, sink slowly down. Hands onto the ground. Back up, roll slowly with the round back up. Backward shoulder roll at the top. Feet together, breathe in, lift the arms up. Breathe out, lean back, draw the shoulder blades together. In and up. Out, back. In and up. Intertwine the fingers and reach high, breathe in. Breathe out, reach in front, hold the back. In and up. Intertwine the other way around. Out, reach in front. In and up. Out, lean with long arms back. In and up. Out and back. Into the middle. Out the hands down. Breathe in the hands up. Out and down. In and up. Bring the hands to touch and lower the hands down to heart center. That was the scenario. I thank you very much.